for soil. So your lateral pressure at this location will be K active time Q, because you are on the active side. Keep going. I will take care for this point. Your vertical pressure at this point equal everything above this point. So we have Q and we have gamma soil time H1. That means your lateral pressure will be K active time your vertical pressure. Keep going. I will take care about this point. What is the vertical pressure at this point? Everything above. Everything above. What do you have above? We have Q. We have gamma soil time H1. We have gamma soil bar or dash time H2. That means your lateral pressure will be K active time these parts. Hey, wait. What is the difference between gamma soil here and the gamma soil here? Anybody know? Yeah? So your gamma here is called gamma saturation. Gamma saturation. But your gamma here called gamma dry or gamma soil, the normal gamma. For maybe you have a little bit of water, but this one is submerged with water. So it's called gamma saturation. So I will use this gamma saturation? No, because gamma saturation is a combination between soil and water, both of them on the same value, but you take care of water before. So what is the value here? Your value here equal gamma saturation of soil minus gamma water. So this term will be gamma effective, called effective unit weight of soil. In soil mechanics, everything will be covered for this point. Gamma soil, gamma saturation, gamma effective, all of this stuff. And you will learn a little more about the soil prism. You have air, you have water, you have solid. So you can figure out what is, we have many parts in this topic. Anyway, so if you have water table, so we have gamma saturation of soil. This is not the gamma I will use in lateral pressure, but I will use something called gamma effective. Your gamma effective equal gamma saturation minus gamma water. So we have a value here, we have a different value here, we have a different value here, so we have something looks like this. Two trapezoidal. I can divide these two shapes to many shapes which are familiar. The first rectangular, triangle, another rectangular shape, and another triangle. Once you convert your pressure to forces, I can figure out how much moment at the base of the retaining wall. Let's talk real example. Remember, I'm talking about basics for retaining wall. Whatever the type of your retaining wall, any type will be solved by earth pressure. First, draw your pressure on the retaining wall. Once you draw, so you have different structure analysis. If you have structure analysis like this one, so you have beam supported here by hinge and supported here by another hinge. This location and this location. Put your lateral force, whatever the shape, draw your bending moment, draw your shear force, draw your axial force, go ahead and design. So the first most important step in retaining wall, what is the load? What is the pressure? What is the soil pressure? Let's keep going. We have a retaining wall, and we are looking for active and passive lateral forces. Be careful, I'm talking about active and passive lateral forces, not pressure. To calculate your forces, I need first to calculate pressure, then convert this pressure to force. First step before starting doing anything, which side is active and which side is passive?
Right.
This one is active, will be the active side. This soil would like to push this retaining wall away. So this side will be your passive. Do you have water table? Do you have groundwater?
No.
No. Do you have additional load, surcharge load or something like this?
No.
Q equals 0. Okay, let's start with the, but before starting also, you decide this side will be your active side. What is the value of K active? 1 minus sine phi divided by 1 plus sine phi. What is the value of phi is given. For this soil, your gamma equal 18, your phi equal 30. So sine 30, sine 30. What is the value? 1 minus sine 30 divided by 1 plus sine 30. 0.33. This soil and this soil the same. As you see here, this soil on the passive side with this soil will be the same. Gamma equal 19 and the phi equal 24. So your K passive equal 1 plus sine 24 divided by 1 minus sine 24. What's the value? 1 plus sine 24 divided by 1 minus sine 24. Your value equal 2.37. One more time. One minus sine 24.
2.37.
2.37. Okay. Or 2.4. I'm looking for what is the stress here, what is the lateral stress here, what is the lateral stress here. Or you can say, hey, wait, do you have any change in soil type or water table or something related to soil between this point and this point?
No.
No? So only 2 points will be enough. One at the top and one at the bottom. If you don't have any change, okay, one at the top and one at the bottom. What is the vertical pressure here? Your vertical pressure equals 0. We don't have anything above this point. Okay, your lateral pressure will be K active time your vertical pressure, which is 0, your lateral pressure will be 0. What is the vertical pressure here? Your vertical pressure of soil, everything above this point. What do you have above this point? We don't have surcharge. We have soil, gamma soil, time H. What is the gamma of soil here? 18. What is the H? 6.7. What is the value of pressure? It's very easy. 18 times 6.7, your value will be 120.6 kilonewton per meter square. But I'm looking for what is the lateral pressure, not the vertical pressure. Your lateral pressure will be K active time your vertical pressure, 120.6. Your value of K active is 0.33. Your value will be something around 40 kilonewton per meter square. So your stress here is 40. Your stress here is 0. So your value or your shape of pressure will be one triangle. This value is 0. This value is 40 kilonewton per meter square. This shape called lateral earth pressure or lateral active pressure. But I'm looking for lateral active force. Can you convert this pressure to a force? Yes. How can I convert this triangle to one equivalent force?
Area.
From structural analysis. Yes.
Multiply them one third.
At 1/3 of the height. The location of your force will be at 1/3 of 6.7. So 6.7 times 1/3. This height will be 2.23 meter. What is the value? This value will be 1/2 time 40 time 6.7. Do you agree?
Yes.
1/2 times 40 times 6.7.
134.
Your value 134 kilo Newton. Let's talk about the passive pressure. So, to summarize this calculation, your retaining wall has an effect of lateral force equal 134 kilonewton as effect, lateral effect of this soil on this step. So if you don't have something or anything on the other side, I believe this force will push this retaining wall to move, to slide. You have only some friction here, maybe not enough. So I think this force will push this retaining wall to slide. We will talk about sliding and overturning next slide. But anyway, let's talk about the other side. We have some soil, not too much, but we have a little bit. Do you have any change of soil between the first point and the lower point? No. So only 2 points will be enough. What is the vertical pressure here? 0. We don't have anything above this point. That means your lateral pressure will be K active times 0. Your value here will be 0. What is the vertical pressure here? Everything above this point. Actually, gamma soil times H. Your gamma soil, the type of soil in this side, which is the same, 19.
It's K passive, right?
Yeah, I'm talking about vertical pressure first.
Yeah, but you wrote K active over there.
Oh, I'm sorry.
It's K passive. You're right.
Yeah,
Sorry.
thank you. 19 times your H, which is 2 meter, equal 38 kilonewton per meter square. Your lateral pressure will be K passive times 38. What is the value of the K passive? 2.37 times 38. You have a good value. What is the value?
90.
Sure? Okay. 90 kilonewton per meter square. So your value here is 90. This value is 0, so we have triangle. Can you tell me how can I convert this triangle to a force? Yes. Your force will be at 1/3 of the total height. So 2 times divide 3 meter. What is the value? 1/2 times 90 times 2 meter equal 90 kilonewton. So we have here something like this, 90 kilonewton. However, although you have lateral pressure from this soil equal 134, but we have reaction here from the other side, 90 kilonewton. So which one will be cause sliding or overturning, or you have stability? I'm not sure what will happen, but right now we can calculate how much force from this side, how much force from the other side, how much pressure from this side, and how much pressure from the other side. It's very important to understand this point, very important, that at any point inside your soil, at this point, we have two different value of pressure. If you are talking about vertical pressure, gamma H. If you are talking about lateral pressure, your vertical pressure time K, and your K may be K active or K passive. But if you are talking about water, both of them will be the same because pressure of water is equal in all directions.
Dr. Amon, just based off of the picture that we drew there, it almost looks like it's helping the active soil or the passive soils.
If you are talking about, right now I'm talking about the lateral forces.
Okay.
But if we would like to analyze the stability of your retaining wall, we have a little bit of soil here over this bar, so we have weight here, W. We have weight of your retaining wall. We have friction between your retaining wall and your soil. Put all, we have a little bit here. That's right? Put all of your forces, then go ahead and make stability. You got it?
Yeah.
I'm talking right now only about the lateral pressure, not all forces, okay?
So we analyze all the soil, even though it's not on the legs of the retaining wall itself too, right?
Here?
Yeah, like the shape of that we analyzed.
Yes. You mean we don't have soil here? If
I mean, we went and got 6.7 instead of 6, like the height
yeah, 6.7 from this point.
from the bottom of the footing or
Yeah.
the bottom of.
Yeah, because your force here is trying to push this part even and push this part. Okay? I will talk about stability for the whole retaining wall. If you would like to talk only about this part, that's enough to calculate what is the value here and what is the value here and draw little triangle. Okay? Just a little bit about we are well doing today.